Recording in progress.
All right. Hello and welcome to our Q4 Industrial Manufacturing webinar put on with PTZOptics, Detect It, and Comtronics. This is our second webinar. So in our most previous webinar, we really talked high level about computer vision and AI and industrial manufacturing. Today, we are going to be building a neural net live within 1 hour. So joining me to do that is Rick DiLoretto and Kit Coolwick from Detect It. How you guys doing?
Good. How's it going?
Doing great. This is going to be the exciting one where we're really going to build a neural net live. So I cannot wait. And also joining us is Jim Hagen from Comtronics. Thanks for joining us, Jim.
You bet. Hello, everybody.
I'm guessing everyone tuned in on our last webinar, but I'll do a brief introduction for myself and I'll let everybody do a brief introduction and then we're going to jump right in. So I'm Paul Richards. I'm the Chief Revenue Officer at PTZOptics. We make pan tilt zoom cameras with an open API that Detect It is going to be using today to control the robotic cameras to make their AI software come alive.
And I'm Rick DiLoretto. I'm Chief Operations and Marketing Officer at Detected AI Software. We make AI software that anyone can use to make neural nets for manufacturing and quality inspection systems in manufacturing.
My name's Kit Coolwick, Applications and Sales Engineer here at Detect It, and we'll be actually creating a neural net just like Paul said today.
And your job is to go into the field and make this happen at our customer.
Correct. Actually deploy solutions onto the field, teach people how to use neural net technology in tandem with PTZOptics cameras for unheard of and very fast deployments of solutions.
And I'm Jimmy Haugen. I'm Vice President overseeing marketing and sales globally for Comtronics. We provide industrial computing solutions, and Detect It and PTZ are leveraging one of our embedded computers that you'll see today.
Awesome. So today is the day where we're really going to build a net and show how all of this works. So excited to have this group of industry leaders here. And the topic is creating a brand new neural net. What does it take to do that? And we're going to be using Detect It, a Comtronics computer, and a PTZOptics camera together to build a neural net. So we're going to jump right into it.
So, Paul, if you would allow me, I'm going to share my screen real quick and just show everybody the setup so they understand what we're looking at and how this works.
Sure. Got it. Oh, right there.
Actually, I just wanted to see my camera. It's best way.
I think if you just hit stop sharing and then tilt the camera to the setup.
So this is the part we're going to be examining today, making a neural net to look at several different things on here.
This is a Tesla battery penthouse, if anyone's interested. So we'll be doing a couple of positions. We'll jog the PTZ camera around to those unique positions, and we'll do some quality inspection. Are parts installed correctly? Are they presence or absence or not? Rick's showing off the pan tilt zoom camera.
We got it mounted about 4 feet above the part.
And then just like Jimmy was stating, here's the Comtronics PC that we'll be running the station from, industrial built computer, and I'll let him give you the details on that.
So That's our simple setup to get this done today. And this doesn't really vary much from what our customers would be doing on the plant floor.
Ready for me?
Ready for you?
Kit, you're in backstage, so just hit that bottom right button to enter. There you go. Beautiful.
Can everyone see my screen?
It looks like it's coming up here. Yep.
So this is the Detect It Net Builder homepage where we will actually be developing our neural net to detect whatever we want to detect. There are pretty much only 3 steps to developing or training this AI model, and that is to step 1, collect your data or video. Step 2, label or annotate that video to create a study guide for your student to learn. And step 3 is the final step, which is to actually do the deep learning training on your PC so your AI starts learning from those pictures that you provided in your data set. We're going to go ahead and jump into Net Data Collector. This is going to list all of our projects that we might be working on as an engineer or as a developer. Today, webinar demo. Penthouse.
Is your mic on?
And I typically also have a date for when we started the project. Within the project, you will have a series of clips or videos or images, whatever you want to refer to them as. They can be individual clips, and we will start creating a clip now. Call it clip 1. And now we can actually start accessing our camera and start collecting or recording some video. So I'm going to add frames to this project. Our source for these frames is going to be an IP or network camera. I already have it established in my list. So right here is camera 182. And you can see this is currently live field of view for the camera. So now my job is to drive this camera to get optimal fields of view to train our neural net. So I'm going to add a PTZ dock. I'm going to select my camera 182. And I now have free range to drive this camera wherever I might want. You have zoom control, focus control, motor control to drive it in different directions. A lot of capabilities with these PTZ cameras, fantastic cameras.
And Paul, this is not using
I've already
your
set a couple
software.
of preset positions, but just to kind of show the control and the ability to set up to 255 presets per camera. I've already set up preset number 202. So if I hit move to position, you can see the camera automatically drives to that designated position. So we are going to train 3 positions here today. One is going to be this clip installed or not installed. Position 203 will be this bolt installed or not installed. Something similar to that. And then our final position will be 204. And that will be this fuse is either installed or not installed. So just to give you an idea of what we're looking for, now my next task is to actually record video of these different states. So I'm going to go back to position 202. And I am going to start recording some examples of this clip not installed. So start capture, maybe move the clip around.
Yeah, you definitely want to move the part around to get rich content.
Correct.
That's one of the differences between us and other AI programs is we're not picture-based, we're video-based.
So I just hit stop, and now I will install the clip into the position. Start recording again. And just slight adjustments so it's not the same image over and over again. I can now review this clip and make sure I have good frames. I can now save and exit and create a different clip for position 2. So I'll call this position 2. Access my camera again,
which is just an IP address.
which is just an IP address.
It could be any camera on your network, anywhere in the plant.
Correct. Add PTZ doc again.
Paul, talk a little bit about the difference between us flying that camera around from within Detect at NetBuilder and how your PTZ software flies that camera around, because I know there's different ways of doing it.
Yeah, so we're using a PTZOptics Move 4K camera. And just in general, those are available with 12x, 20x, and 30x optical zoom lenses. And like a 30x, which would be the most powerful lens that we have, can get a head and shoulder shot of a person from up to 75 feet away. So, in the situation here, the camera is only about, 4 to 5 feet away, but we're talking
Correct.
about zooming into very small parts. So we have a calculator on our website that kind of gives you an idea of how much you can zoom in. But that zoom, when you're every time you're zooming into something, you have a pan, a tilt, and a zoom variable. And that can be saved into a PTZ preset. And so that's a little bit like what Kit's doing there is he's saving a preset so that he can recall that. And some of the demonstrations that I've seen is really incredible where there's a flight path and the camera can zoom into all these different locations to check these unique pieces.
Yeah, so this module you're seeing now is actually emulated the PTZ controls, but it's within the NetLabor module. So actually, it's been recreated with PTZ's blessing, so you can actually control the camera from within the software. And then as far as the zoom level, for us at Detect It, we like at least a 10 by 10 pixel area of whatever it is you're looking at a minimum to be able to look for defects. So whatever zoom level you need to get a minimum 10 by 10 pixel area of that defect is what we need to go to.
So I'm just going to our final position here, accessing the camera one more time. And I'm now going to record one more short clip. Fuse not installed. Now the fuse is installed. Show it some different examples, a little bit of movement on the part. Hit stop recording. And now I can review my clip that we just recorded. So I have 2 clips in my video. This is technically now position 2 and position 3. Clip 1 became position 1 only.
Hey, Kit, talk about how you didn't even stop the camera that time when you put the fuse in. It got your hand in there and everything. Why is that
Correct.
okay?
Yep. It's just a continuous video. You can always go back later if you want to delete or remove any frames from your data set. But if normal operation is for someone to place their hand in front of the camera or to install the bolt or to install the fuse, try to show the AI as much realistic data as you can. Mimic production to the best of your ability so then you ultimately yield the best performance when you run in production once your neural net is trained.
Gotcha.
So right now I'm just kind of fast forwarding through the video, watching any data that might be too blurry or unnecessary to add to the training. I could also start removing some duplicate images that I have in my data set, but for time's sakes, I think everything is looking okay. I'm going to skip right to the end where you can see the fuse is now installed. And now
Oh,
my,
Kit, I think it's also important to say that if you had additional instances of any of those parts or conditions in the field of view, they would have to be labeled as well, right?
correct, yep. Any instance or example that you see in your field of view, you need to label and hence not to confuse your neural net when it goes to do the deep learning stage of the process. So I'm going to now save and exit from this clip. I'm going to start with position 1. And now my job is to add labels or potential answers that this neural net is going to be trained to provide when we eventually run in production. So I'm going to add labels to my label list. I'm going to call it clip 1 installed, or maybe I'll just call it clip installed.
And we're not seeing that pop up. There's normally a pop up here where you just
Oh,
add a label and pick a color.
let me show that to everybody real quick. I think I should be able to do it. Content only.
Just a
Entire
different
screen.
sharing option, maybe.
Yeah, there we go. Can everyone see both screens now?
Yes.
There we go.
Perfect. So I'll do clip installed. I'll copy this name, paste it in here, and we'll obviously do clip not installed. And you can associate any color boxes that you want to any of your labels. So I would think installed correctly would probably have some type of green label. Not installed correctly would be a red label most often. And then we're going to do bolt install. I should spell it right. And you can title or create these labels to be any text that you want them to be. I'm just kind of picking and choosing something that correlates to what we're detecting. And then
So what
last is going to be
what this
future.
means is this is what's going to show up in the net runner when it detects those items or those conditions. So whatever you type here is what the
Correct.
label will say when it finds it.
Correct. So I'm going to choose red again for my not installed labels, green for my installed labels. And we're going to go ahead and apply those labels to our project. So now my job is to just go through our study guide that we've recorded with our images or our video and label how we would correctly train, just like another human being, to watch this camera's field of view and provide answers to what they see. So I'm going to draw a box around the area that indicates to me that this clip is not installed. I'm going to select that label in my label list, and I'm going to apply a tracker to this data so I don't have to apply that box for all of my frames. I can simply fast forward through my video clip with my boxes being applied for me automatically using detected software.
Talk a little bit more about trackers. What does that mean, Kit?
Yep. So trackers are designed to help you, the engineer, get through or label your data as fast as possible. Typically, when training neural net technology, the bottleneck in terms of speed is typically this labeling process and actually doing the training of your neural net. So if we can speed up this process by using pixel trackers, and notice my hand is now covering that area, so I don't want to teach the AI that my hand is what not clip not installed means. So I'm going to skip these, not skip these frames, but just not label them. And then as soon as I can see that area clearly of clip not installed, I'm going to label that even with the hand partially occluding that field of view, because that is something that can happen in the real world in production as well. So I'm going to continue to track those pixels, fast forwarding through my video.
And there's 7 different types of trackers there.
Correct.
And
Each
in
for
order of their
tracking.
usefulness, some do things better than others. Some are better for slow moving items. Some are better for fast moving items. Some are better for items with occlusion. Some are better for items that leave the screen and come back.
Exactly right.
So in a sense, what you're doing is making a series of flashcards.
Yep, giving it a photographic memory, so to speak, almost. So I'm now already almost through most of my clips for not installed. Pretty soon it should be switching to installed. And we will change our label accordingly. Yep, so we got our first frame here at frame 164. We can apply the same box, but obviously the label name is incorrect, so we right click, change label name going forward to clip installed, and again start fast forwarding through your data set with the correctly drawn label, teaching our artificial intelligence what clip installed versus clip not installed visually looks like.
So there's actually two boxes there, Kit. Explain those a little better so people aren't confused.
Great point. So there's technically two boxes on the screen anytime we apply a tracker. The neural net is totally blind to the trackers. They are just a tool to help the engineer label their data set in a faster manner or to get through their data set as quickly as possible. Well, even with my finger maybe blocking most of it, I can still see that clip is installed into the proper location. I might condense this box a little bit just to fit the yellow. And then continue fast forwarding. And just in a matter of maybe seconds or a minute or two, we're able to label hundreds, maybe even thousands of frames of data utilizing video and pixel trackers to teach your artificial intelligence. Again, videos playing through, slight differences in each image, best that we can accomplish. And now just like that, 289 frames of data already labeled. I'm going to now save and exit real quick. We'll finish up our second clip with our other two positions. And then hopefully, again, just a couple of minutes, we can label all hundreds of these images in our data set. So again, we got bolt not installed. Select that label. Draw a box around that area that tells me or teaches you that this is bolt not installed. Apply a tracker again to those groups of pixels and simply hit fast forward.
And you would not want to do a much bigger area than that. What you typically want to do is find the most characteristic area of that label or that identification.
Correct.
Like you wouldn't want to put a box around that whole red plastic area as well, because there's more there than just the bolt being installed or not installed.
Correct. Focus on the group of pixels that are actually changing for your two states, or maybe it's multiple states, but focus on the group of pixels that actually gets affected or changed when teaching the artificial intelligence. Let's go. Real quick, I'm just getting a little lag here. Sorry guys, computer's just moving a little slow here for a second. I'm gonna just try restart.
Okay.
Real quick.
Jimmy, you want to talk about the different models you guys have that'll support AI?
Yeah, absolutely. So we have two series of industrial PCs right now that we've launched for any sort of AI software technology. It's our 800 series and our 900 series. Some of the important things when it comes to hardware, when we're talking about AI software technology, is they're going to be very intensive from an inferencing standpoint as well as a training standpoint. So sometimes it's going to be maybe processor heavy. Other times it will be more GPU heavy. The nice things about our units is when you have a lot of horsepower and GPUs running inside of a system, ours, the one that they have currently deployed is really completely fanless. So we have 3-layer kind of heat dissipation. One is internal. We have heat pipes that are on the processor. Two is, I think when you saw the physical PC sitting there, is it looks kind of like a radiator on the side. So that's what's called a heat sink, which dissipates heat from the unit. And then on the side where the GPUs sit, we will have venting. Obviously, GPUs do have fans. Majority of them do. So there's 3 layers of heat dissipation built into our system.
Nice.
The other thing too is you have the ability to run either USB-based cameras or PoE cameras. When we talk about USB-based cameras, is the way that our solution is designed is each USB line is on its own single line, own single controller. So a lot of consumer grade solutions, they're going to have a hub. So it's a shared hub. So you don't get really the speed and power quality that you need to run these high-end cameras. So that's really important. Also is our solutions, there's a lot of different IO based on, the customer solution and the needs. So a lot of PCIe expansion slots. You can have a single GPU. We have the ability to drop in 2 GPUs, ability to put in different PCIe cards, so PoE, and things like that. So it's a true industrial solution. All the components are industrial, the chipsets, industrial 15-year lifespan. So it's really built for this purpose.
Excellent.
Which is a huge advantage too when using Detect-It. The ability to run mini USB cameras for certain applications has been a huge advantage for us deploying solutions. So the Comtronics PCs are one of the few, if not the only, pieces of hardware that can support a system with such requirements.
So you did the fuse missing, and now we're labeling the fuse installed.
Correct, yep. So I should be finishing up our last position here in just a couple of seconds. Fuse installed.
Hey, kid, I had a question for you on the bolt installed.
Yeah, please.
Um, there was a slightly smaller bolt above that one and to the left that looked a
Mhm.
lot like it. Should
Mhm.
you label that one as well? Is it going to confuse the net in your mind?
So, if I have specific examples or pictures where that bolt is present and I am teaching the AI to ignore that, because just like you said, Rick, they do have slightly different visual cues. One is smaller than the other one. The AI is learning to ignore it because that is how the teacher is presenting the study guide.
Oh,
So
so
even with
by
bolts
not
that are
labeling it, you're making it
cor-
more obvious.
correct,
Gotcha.
exactly right. So now we finished in just a couple minutes our, almost 700 frames of data. We're going to save and exit from our project here. There's our 2 clips that we created. Clip 2 obviously has both positions, which is totally fine. We're going to now copy our project name. We're going to navigate back to our home page. We've completed steps 1 and step 2, and now we just have our final step 3 to finish. We're going to go ahead and add a new training in, copy that name, look for the project that has that data that we just labeled in it. There's our 2 clips. We can pick and choose which clips to include or not include in Detect-It software. You can also skip empty frames or do a limited selection if you were only able to finish a portion of a certain video that you recorded.
Hold
But
on a
we were
minute,
lucky
Ken. Hold
enough.
on a minute.
Please.
You clicked one button and it looks like Detect It set every single option for the training of this neural net in one click.
Automatically. If I just copy my name and select my project, all my other parameters are automatically set by default, courtesy of Detect-It. a recommended duration time or iteration count for how long the AI is going to be training for, a recommended batch and subdivision there for best performance. But we can also change the training speeds if we are limited on time before we can test or deploy this neural net.
What's the trade-off from training slow to training fast?
There is a slight performance degradation from going from slower training to a faster training. It's technically not using as many of the images that are in our data set to do the training, but the performance difference is very minimal, and you can still get very, very good trained neural nets, even with a fast training mechanism.
So let's say
Go ahead.
somebody is very versed in this, in AI, and they, for whatever reason, wanted to change these default settings. Is that possible too?
Of course, yep. We have an advanced setting tab right here that typically is our last section to choose from. If you are more of an experienced neural net programmer or trainer, you can actually totally customize most, if not all, of these settings here. And we even give the user direct access to the configuration file that is used for the parameters in the training. We give you access to edit this configuration file if you choose to do so. And there are certain reasons to edit or to change from the default settings for specific applications if needed.
And you can even change the type of net.
Correct. We have different YOLOs that we support as well as ResNet, different model or brain configurations for different applications as well. By default, detected software trains a tiny YOLO 3, but like Rick just mentioned, and here in the dropdown, there are 5 different brain structures that we currently support that could turn into more as the future, as the future comes. We also support continued training if you don't want to train a neural net from base or from no knowledge at all, so to speak. If you've already trained a model, you can continue that training to, again, make it smarter and smarter and smarter, hypothetically or hopefully not making any mistakes in the future as it's been trained. I'm going to go ahead and save these settings. I'm going to kick off a fast training really quick. And this will now load up those 2 clips into the GPU's RAM to start commencing that deep learning training. Now, what is deep learning training, right? It's very simple. It is just like teaching a young child maybe to learn the ABCs or the difference between a cow, a pig, and a horse. You might show it a cartoon example on a flashcard. We are training this AI model using the exact same technique. Each of our images are flashcards that we are using to train the AI model, asking the AI model each time, what do you see on this flashcard? What do you see on this flashcard? And through that iteration process, it is comparing the answers we provided as the trainer or the teacher to the answers that the AI model is providing and giving a score, correcting, confirming those answers depending on how closely they are to the answers the teacher provided in that study guide.
Jimmy,
So
talk a little
here's,
bit. You had spoken earlier, Jimmy, about CPU versus GPU. So what's happening right now is almost 100% GPU based. You want to talk about how the different models of Comtronics computers would handle this step of the training?
Yeah, I mean it really depends on the software application. Like Rick just said, is right now it's really GPU based, but if it is set up and you need more CPU, we it's completely up to you on what type of CPU that you need based on the application. So we support all the way up to i9 processing, 128 gigs of RAM. And then from a GPU standpoint, there's a lot of different flavors of GPUs. So if your training is more complex, you can certainly get a more powerful GPU, or you have the ability to drop in 2 GPUs into our solution.
Sweet. And Kit, talk a little bit about what people are seeing on this screen.
So right now we are displaying a graph of performance that the AI is providing depending on the answers it's giving us. So we have a score value or an accuracy level of how close are the detections that the AI model is providing, how closely related are they to the correct answer we, the teacher, provided.
And we're
So
already up
kind
to
of playing that
98,
correct confirm.
99%.
Exactly. Yep. So it trains very fast, very quickly to a highly successful level. It could be training out some potentially bad answers or just reinforcing some good answers right now. So we eventually get a more robust model in terms of testing correctness.
What
And just
happens?
go ahead, Brick.
I was going to say, what happens if this graph were to look really weird, like a roller coaster, you start going up and down and up and down? What might that be an indication of?
Well, that's usually a good sign, Rick. That means that a lot of learning is happening up to the model. It's making some assumptions that are correct, and the accuracy score is getting higher. And then it might make some assumptions where it's not correct and learning from those mistakes. So you might see the accuracy score start to drop a little bit. That is not necessarily a bad thing. It means that it is learning what you are trying to teach it through those series of images slash videos.
So typically, Kit, you would spend the majority of the day preparing this model, and then when you went home at night, you would kick off the GPU and let it run overnight.
Correct. Yeah. Most of our deep learning training happens overnight when engineers and people aren't working on the machines, because this is all pretty much an automatic process here where you can watch the graph if you'd like, but most of the time you're just looking for the best score at the end of the deep learning.
Gotcha.
Rick or Kit, can you talk a little bit about detected and the need for storage on a physical piece of hardware? Is that important to your end customers or to your application?
Great question. So storage is somewhat important because to train these models, you obviously need to store or record videos or images, and that does take up space either on a hard drive or NVMe. Um, Once the AI model is trained, however, you do not need to keep that source information or source material because that AI model is now trained and recognizes or has learned what it needs to learn. So once an AI model is trained, the size of that model is only about 33 megabytes. So just kind of on that threshold of being able to email from person to person. But typically, if a continued training is also happening, you do not need those original source images either. It just needs to learn on the new images or new data that you're showing it because it's already learned from those previous images. So yes, there is some storage requirements needed, but most of the time it is not long term to store those images once you have a working model.
And Kit,
So
does
on
that?
our
I'm sorry, Ginny. Wait 1 second. Kit,
yep.
does that model size change? Like if you have a net with 2 labels versus a net with 200 labels, does that file size then go to like 2 gigs?
Nope, it stays the exact same size, whether it's trained on one label, 10 labels, or 100 labels. The only time the size of the file does change is if we change our brain structure from the tiny version to a full YOLO version. It does double in size there. A slight difference, just to get into it a little bit, between the full YOLO and the half YOLO is larger brain size, the ability to train more information to that model, but it does take longer to get to a working level at the start. So typically why most applications start with a tiny YOLO to begin with.
Okay, go ahead, Jimmy.
Yeah, so on our Comtronics devices is we have from a storage standpoint is we have two front bay external storages that can house up to 4 terabytes of data. And then internally, you have an additional two, so you can get 8 terabytes of storage internally as
Tons
well.
of
So
room for storage. Yep.
there's tons of room for storage.
And that becomes more prevalent, Jimmy, when you start getting into higher resolution applications where maybe 4K is required over 1920 1080 resolution. Maybe you're
Right.
training a larger number of labels, so more data is needed. So yes, very helpful to have that large storage bucket or 8 terabytes, like you said, to store data and images.
Kit, we have a single PTZ that was looking at those 3 different areas that we're going to be focusing on. But if, let's say, our cycle time was quicker than that, we certainly could have put 3 fixed cameras in place of that. Isn't that correct?
100%. We try to always recommend PTZ cameras to our customers because we limit the amount of customers that the number of cameras the system is required to yield the results desired. But if cycle time is tight, where we have to do all of our inspections within, say, 15 seconds, 30 seconds, sometimes a minute in some applications, we can deploy more PTZ cameras to divvy up those responsibilities, or like you just mentioned, do fixed mounted studio cameras, which PTZ Optics also offers, to do instant detection, information, and instant detection upon once something is in the field of view of the camera. We don't
Paul,
require any fixturing, nesting, stop stations, because we operate in video. Detected is usually running live all the time, 24/7.
so Paul, is that going to make any difference to you guys if it's a PTZ or a studio? It's a move or a studio. Is there any difference?
Yeah, so we have, robotic cameras that can do pan, tilt, zoom, and then we have static cameras. In fact, the camera I'm using now that's looking at me right now is static because I'm not moving, right? And so you can, if you have a lot of cameras that you need to deploy, you can save a significant amount of money using static cameras. Our studio 4K cameras, while they are kind of point and shoot static, they do have optical zoom integrated. So you could still zoom in quite a ways and have these cameras in ideal locations, but they're not quite as flexible if you're going to be zooming into multiple areas.
Gotcha. But the resolution and then everything and the frame rate is all the same as the PTZ.
We use almost the exact same sensors and lenses so that if you are mixing and matching cameras, they will have very consistent quality.
Cool. Kit, tell us how you think this training is going, looking at your numbers.
It's very, very accurate so far. I'd love seeing, as close as we can get to 100. Getting to 100 is not very realistic and never really happens, but getting as close as we can is a very good sign that our AI model is learning what we're teaching it based off
We're
those
at
images.
99.8 right now.
Yep. And I do have the ability to save a backup or save a version of this model at any point in time. Detected also will save multiple versions at every 1,000 iterations, so you can deploy whichever version of your AI model is yielding the best score, the highest accuracy number. So,
Is there a reason that a version earlier than a later version would actually run better?
um, Well, like we mentioned before, there can be assumptions that are made during the training process where the AI model does make an incorrect assumption. If you happen to deploy a model when that was occurring and you did see a lower accuracy score, I wouldn't recommend deploying the one with the lower accuracy score, but it can happen in the middle of training where you start to see kind of rises and falls in that accuracy percentage depending on what it's learning or the answers that it's providing.
Yeah, I suppose it's like a kid. If you went through the flashcards, 20 of them and got 15 wrong, you wouldn't want to take the test.
Exactly.
You'd want to
Exactly.
go through it a couple more times.
Or you just wouldn't expect that student to score very well on the test when the test does come.
Gotcha.
Rick,
But
one more
we
thing on
obviously,
the oh, go ahead, Kit, sorry.
no, go ahead, Jimmy. Sorry.
No, I was just gonna say one more thing on the hardware side is so Comtronics, we design, manufacture, and support all of our products in-house. So the PC that they're leveraging right now was, designed for Detect-It based on a specific use case. And this comes up a lot, and I think maybe Rick can share a little bit too. It is with having consistent deployment of a industrial computer that's tried and true and almost quote unquote certified, it makes the deployments a lot easier. And then also you have someone that can support you. So the consistency in that I think is important to the end customer. Would you agree, Rick?
Yeah, I would agree. We don't want to take a lot of calls here. We're a software company to help people fix their hardware. That's not really our call. I mean, we can try and help customers figure it out. But a lot of our customers don't want to put consumer grade hardware on the floor. I mean, they can. Our software is pretty PC agnostic as long as it has an NVIDIA GPU in it. But Jimmy, why don't you talk a little bit about Comtronics versus consumer grade PCs, how
And
that difference and how what that means long term on a factory floor.
And I'll just say quickly that Carl has his hand raised. So Carl, if you just use the Q&A feature to ask a question, we'll do our best to answer them. But go ahead, Jimmy.
Yeah, I think The biggest difference, so when you look at a true industrial PC, I mean, all the components are going to be industrial. So it is designed, and I referenced that the one that they're leveraging right now is a completely fanless computer. So it is designed for manufacturing environments, tough environments. And again, all the components are built for longevity. Internally, it's important that we do manage so all the design and manufacturing, and we have a whole entire support team. So you're going to get not only the longevity of the product, but also the scalability. So as we were talking about storage, you can add storage. If you need to bump up RAM at any certain time, you can. If you need to drop in another GPU, you can certainly do that. So again, when you talk about consumer grade, a lot of times is the way that they're designing those chipsets. You buy it and 2 years later, it's already end of life, and they're just not built for the industrial environment. The other thing we run into is if you're a larger company and have multiple locations, it's extremely difficult for your technical team if you have a smorgasbord of different computers that are deployed. It's very hard to troubleshoot and very hard to support. So that's one of the reasons where when you leverage a true industrial computer and you have a company that is based here in the U.S., we support all of our customers out of our Georgia facility. So
Awesome.
did that
Kit,
answer your question, Rick?
absolutely. Kit, you think
All
the
right.
student's ready?
Yeah, I can force it back up here real quick.
So we're not even gonna let it finish.
Yep.
Numbers are looking good, solid up in the 99.9s.
Yep. So I'll just go to my list here. I'm going to copy that name.
And you're just doing that as a shortcut.
Correct. Yep. And I'm going to go now to my deployer module, which no work is really happening here in this module, but we're going to actually send our neural net to our second bit of software, which is Netrunner, which will actually connect to the camera again and run in tandem that AI model to give us the detections we're looking for. I'm going to paste that in there. I think I'm actually looking. And then I'm looking for the best score, which here is 99.38. I'm going to deploy it to the detected office, my PC, create a bundle, save and deploy. And now I'm looking for success and success, all good. So we are now ready to go into Netrunner software to actually run our model and see how smart our student is. So I'm going to hit add camera doc. I'm going to select my neural net model that we just trained. I'm going to select my camera, 182, and I'm going to run that model. So it's already detecting fuse present. I'm going to detach my labels real quick so everyone can clearly see.
So this
I'm
isn't
gonna
your
add-
training data. This is actually running live from the PTZOptics
Correct.
server.
Yep. And just to show you, there's my hand in the field of view. Move the fuse from location, and now the AI model sees that that fuse is no longer present. Right? Even if I place it directly next to it, it knows it's supposed to be in this location in order to pass the check. I'm going to select camera 182 again, go through my series of positions. So just to show you kind of an overview, here's the entire part. Zoom into position 202. And right away, it's telling me that I see that clip installed, right? If I
And it was
remove
picking that up as soon as it came into the field of view.
Correct. Just like you and I, Rick, can see when that clip is installed, even if it's maybe from a different field of view or slightly different zoom level than what it was trained on, it is human-like, right? It can still see that that clip is installed with a very, very high level of confidence because of the good training that we provided to it.
Okay, plug it back in again.
Yeah.
So cool.
So that was a bad part. Now it's a good part.
Now it's good, right? And then same even moving to our next position, 203. And you can see even as that clip was leaving the field of view, it was still making the detection. Same with the bolt install. As it's approaching and as soon as it gets into the field of view, right away you're getting those detections, even if they're different position or slightly different than the images we specifically showed in the training. By changing those images ever so slightly, you're giving it a more robust understanding of what you're trying to teach it, and it hopefully will give you that high level of confidence in the correct answer in almost no time at all.
Can you move the part?
Yeah.
Oh, it follows it?
Correct. Just like your eyes will follow something anywhere in the field of view. And you can see that high level of confidence because of our good training that we provided, 99.9, 100%. And then again, even if we go to our fourth position, right away, not installed, installed.
Outstanding. 50 minutes to
Yeah,
make
15 minutes.
a brand new neural net with 6 labels.
And
From
just to
scratch.
kind of show off the Comtronics box here. See if I can get it in focus. I currently have the camera set to a manual focus.
Yeah, you don't want it
PTZOptics
auto-focusing
does
on your camera.
also offer autofocus or a lot of zoom and focus control with their cameras, which is fantastic for setting up different systems. It's like Jimmy was saying, the large heat sink on the side, completely fanless solution other than the GPU itself.
Yeah,
And a
you
lot
can
of
see on the
different
left-hand side there is where the GPU sits, the venting.
Yeah.
And then all the IO is where on the front there.
Yeah.
So Kit, one more thing to finish this up. So 99% of what you did today was in Net Builder, correct?
Correct. Yep. Training the
So-
AI model was pretty much all in Net Builder today.
And this is
And then-
Netrunner. This is the second piece of software. And once that net is deployed, it doesn't need to be connected to Net Builder anymore, right? It's running completely independent of it.
Correct. Yep. Most PCs either have just Netrunner on them, or your Net Builder PC will have both. So you're able to test whatever neural nets you deploy before they might go into a production setting.
And none of this is cloud-based, right? Nothing's going to the cloud. Kit?
Sorry, say that. I didn't hear you.
I said none of this is cloud-based, right? Nothing's going out of your facility or going to a cloud.
Everything is on premises, doesn't require an internet connection at all. So no cybersecurity issues, and IT usually is a big fan of us. So.
All right, Paul, did you say there were questions?
Yes, let me check here. So in the Q&A, Carl said, on the clip installation, can you detect levels of Z access? An example, if the connector was not fully seated.
Yes, the answer to that question is easily yes. I might not mount the camera in a top-down field of view if that was the requirements of the system or the application. From more of a horizon field of view, you would be able to see that kind of Z depth a lot easier. Paul, you might want to step in here, but these are two-dimensional cameras that do also have the ability to do depth sense. Am I correct? Or no?
So we're delivering the video. So essentially, you know, if you need a second angle, a second camera would be necessary.
There you go.
And we do have customers using us for electrical clip connectivity on B side of headliners and fascias.
Yeah. And within Netrunner software, you can run multiple models at once against one camera feed, or you can run multiple camera feeds, all running different models, or again, multiple models, totally customizable and detected Netrunner software. So a lot of functionality with the ability to run, say, 10, 12 different cameras, each running their own model, or even potentially running multiple models doing different things.
So a couple more questions coming in here. What happens if the parts are installed incorrectly?
So just like with this fuse right here, I could have also taught orientation of the fuse to the model, and that would have probably been indicated to me by the direction that the letters or the text here is being written. So if this was maybe the reverse orientation, I could focus on those letters and what direction they are written to teach the model correct versus incorrect orientation.
Or if one side wasn't on the bolt.
Correct. Yep. I could have labeled maybe just this area here to indicate to the AI model that this is what means correctly installed. And also taught it orientation. With bolt position, that's not orientation usually isn't as important, but we can also communicate to maybe a torque controller for torque and angle for certain applications as well.
And Kit, if we realized this after the fact that we needed either incomplete or partial connectivity, do we have to start over at that point, or what happens?
You do not have to start over. You just would add labels to your already recorded images or videos to train your model differently. You would have to retrain the model because you are now giving it additional potential answers that it didn't know before. So your original project data is still good. You just might have to relabel it or label it slightly different. But the model will have to be retrained, and you can, and as we showed, that only takes hopefully 15, 30 minutes for most applications. And you would have your now new model that's trained on all of your detections that it's been trained on.
Gotcha.
Got it. So you can add additional, you can go back
Correct.
in with that same video and keep adding more to it.
Correct.
Another question, and then another thing that I don't know if you really mentioned, but there's scripting involved, right? So you can take action when these detections are made.
That is correct, Paul. We do have the ability to provide extra logic using a script language within detected software. So we have an add scripting module right here at the top.
But
where
you
can
don't need it by
customize.
default.
Correct.
Yeah, Kit, talk a little bit about what happens when we make a detection, how we can connect to PLCs, MES systems.
Yep. So just like Rick's saying, most applications usually once you make a detection, what do we do with that detection? We can save images for evidence or traceability, maybe for you or for your customers if that's needed. We can also talk to external devices like PLCs for automation control. Maybe you want to turn on a bell, a horn, or a light, stop a conveyor, start a machine, whatever you might need to do to trigger automation can happen through Ethernet to a PLC. And then typically we also utilize our REST server to pull or extract metadata or detection data from our AI models, whether it's how many detections are we getting, what is the confidence level in certain detections, maybe location, XY position of our boxes on the screen. Maybe you want to open and close different layouts for different part types or different processes that you're running today versus yesterday, or maybe just earlier in the day versus later in the afternoon. We can open and close different layouts here. Maybe you have 10 cameras that are part of your system that are running today, but you only need 5 for tomorrow, so you can save different layouts. We can also set up communication back to Builder, so you can do automatic labeling. So if your neural net is providing the correct answers, maybe just at a lower level of confidence, we can hit the Show Data Collection button to actually record video in Runner, labeled already, and import it back into Builder for continued or additional training of that model. Like we mentioned, we have PLC configuration here, where we can talk to many different PLCs, even from one PC device that might be controlling a station or multiple stations. We can also communicate with maybe an MQTT server or broker for, again, evidence and traceability, passing along our detection information to make sure systems are running correctly.
All right, got one last question from Josh Gall here. Would it be possible to recommend a setup of a multi-camera system if you wanted to capture a 360-degree view of an item, for example, a gear, wanting to inspect the full part of any damages or discrepancies without manually rotating it?
Yeah, if manual rotation is not an option or any rotation is not an option, we can always deploy multiple cameras to a single PC or to a single system. Some of our systems are 25 camera systems. Some of them are only 2, 3, 4 camera systems. But yes, very easily to view an object in a 360-degree field of view. There are also cameras out there that are more fisheye or create 360-degree fields of view, but usually mounted from like a ceiling.
And you could put cameras on both sides. So if you mounted the part vertically, you could have maybe 8 cameras on the right and 8 cameras on the left and literally do both sides of the entire thing at one time.
100%, Rick. Yep.
Awesome. Well, this has been a full hour, so we are going to keep on doing these quarterly. So in Q1, please reach out to Rick and Jimmy and myself. Let us know if there was something that you didn't get to see, because I think we're just going to get a little bit more advanced each webinar, diving deeper and deeper into what this amazing software and hardware is capable of. So with that, I just want to thank all of our speakers. You can feel free to reach out to everyone. I will just once again, just share a little slide of everybody. Oh, you're already sharing your screen. Don't worry about it, but
Hold on. I just stopped.
you can feel free to reach out to any of us here. We're happy to talk to you about the different products that we support here. And thank you everyone for joining today.
Thank you.
Thanks, everybody.
Thanks, guys.
All right, take care.